So I'm Campbell. I am an infrastructure guy. My company is StackMonkey. I'm doing a solo founder gig right now. So it's kind of adventuresome. I'm writing code and promoting it and talking about the idea. So in order to kind of ease you into that idea, because we kind of have a mixed audience here, I'm going to talk a little bit about the brief history of compute. So it's kind of interesting that compute's been around for a really long time. So it's been around 70 years. So this is the DevOps team. So there was actually 6 women. They were the programmers and operator of the very first electronic computer, which is called ENIAC. Who remembers ENIAC? Anybody read it? Yeah. So ENIAC was a beast of a computer that happened about 70 years ago. ENIAC used 150 kilowatts of power, which is a continuous thing. That's about 1,500, 100 watt light bulbs, if you want to compare that. And it did about 5,000 operations a second. And it was the pinnacle of centralized compute. So that means that at the time that ENIAC was around, it was the fastest computer. It was the only computer, the only electronic computer that could do, basically, you could program it. What's interesting is that DevOps team was kept busy full time because it would burn out a tube once a day. So you can imagine using a computer and every day it would break. So they would have to go fix it. 20 years later, compute is fully distributed. That's phenomenal. So by the time that was 1966, by the time I was born, compute's fully distributed. The day I was born, IBM shipped 30 IBM 360s. And an IBM 360 could do 36,000 operations a second and was about the 5th the cost of ENIAC without converting. So today, I'm sure, how many of you are like a programmer or do operations or at a startup? Raise your hands up real high so I can see you. So a lot of you guys. So you guys use compute on a daily basis. We all do, obviously, with devices. For data centers, data center-based compute is a $150 billion a year market. It's a really big market. What's interesting about it is it's not growing that fast. It only grows about 4%. In fact, that's actually declining a little bit. And there are a lot of companies that are shitting the bed about that, like HP, Dell. Those guys are like sweating this stuff because it's not super profitable for them. It's a thin margin. And what's interesting about that is that the amount of compute per person, that's for all of us, is increasing exponentially. What does that mean? It means that it's increasing at an accelerated rate, and it's not reaching a limit. And by the way, I'm just tossing out all the tablets and laptops and everything, all the devices you guys have in here, I'm not counting that. I'm just talking about servers, CPUs and servers, powerful servers, that it's growing without bounds. I mean, literally without bounds. And it's not stopping. It's not like it's tomorrow you're going to go, oh, you know, we have enough compute, we don't need it anymore. That's not happening. It's becoming faster. So imagine in 9 years, by the time 2023 rolls around, that we have 16 server-grade processors for every man, woman, and child on the planet. That's a lot of processing power. And you think about, what in the hell are we going to do with all that? What are we going to do with that processing power? That's not, by the way, your tablet or your phone. That's like servers. And that's not a maybe. That's a for sure this is going to happen. So you kind of wonder, what are we going to do with all that, with that data? We will, yeah, Bitcoin, right? We're going to always need more compute. That's just an inevitable thing. Either that or it's all going to crash into the ground, right? If you guys haven't watched Ray Kurzweil at Google talk about this, there's a good video that you can search for, and he talks about how it's exponential in growth and about how that's not stopping. It's just an inevitable thing. So this is kind of the Internet of Things argument, except it's the flip side of that. It's the big data side of the Internet of Things argument. So think about all your devices that you're holding or in your bag or that you got in your house or your laptop, right? You think about all of those things generating data, and then there's the flip side of that, which is all the stuff in the cloud or out in the internet that's processing all that data. And all of those things generate lots of data. They generate data when you use them, take pictures, things like that, and all of that data's got to go somewhere, and something has to crank on it. So it's kind of the flip side of the coin, the thing that no one ever really talks about, the other side of the Internet of Things argument. So what's interesting is our demand drives compute efficiency. So you think about efficiency, right? Efficiency is just making things better. Everybody kind of understands that, right? But it's also making more, you know, of what you have, do more. So do it faster. So let's talk about Bitcoin, because we're all on Bitcoin, right? That's why we're here. So the Bitcoin network is currently hashing at around 85 quadrillion hashes per second. Does anybody know how many zeros are in quadrillion?
16.
There you go. It's a lot. And at 3,385 operations per second per hash, that's 287 quintillion operations a second. That's happening right now on the Bitcoin network. That's staggering. So it would take 5.7 times 10 to the 16th ENIACs to run the Bitcoin network. I know this is accurate because I asked Wolfram Alpha, and Wolfram told me that this was the answer. And then Wolfram offered up, it's like, hey, you know, if you multiply by 30 tons, which is how much ENIAC weighed, that system would weigh more than the Earth's oceans. And here's an even more staggering thing, and it would require 50,000 Earth surfaces worth of solar power to run it. That's just staggering to me. I mean, that was 70 years ago. That's nothing. What are we going to have in 100 years at an exponential growth? You can't even imagine that. You can't like put it in your brain. It's impossible. So the biggest efficiency gains come from utilizing excess capacity. So again, if we talk about that, Airbnb is a classic example of that. Who's used Airbnb? Yeah, Airbnb is awesome. So Airbnb makes it their business to make efficient use of capacity, spare rooms. So 300 years ago, there were lots of spare rooms, but not very many of them got rented out to people all over the world. A, because people didn't travel a lot, and B, there was no internet. So Airbnb has made a monster business off of making efficient use of spare capacity. So the public cloud offerings like Amazon, which are infrastructure as a service, are a result of experimenting with compute efficiency. So if we look at that market segment, I'm not going to spend a lot of time on a bunch of graphs because they're boring, but the one that's kind of important is this one right here, which is infrastructure as a service, is growing at 47% a year, and it's not letting up, it's getting worse. It's just continuing to increase. So that hockey stick that you saw on the amount of compute, this graph is a direct result of that. So public cloud is growing like crazy. If we do a projection to 2023, this is advertising, this is Google's business. This is infrastructure as a service. That's the projection that Gartner is projecting. That's a $500 billion business. That's compute on the market for you to consume. $500 billion a year. If you look at Amazon, Amazon owns about, right today, about 80% of the servers that run in the public cloud. How many people use Amazon? Everybody. So yet Amazon only has 9 data centers. 8 if you don't count the one they run for the CIA. They run a data center for the CIA. This is blinking one right here. So it kind of begs the question, are we back in 1946? I mean, come on, the cloud is 8 data centers. That's 80% of the cloud, the public cloud. No, we're not back in the 1946. Definitely not, right? We've got Bitcoin, we've got all sorts of stuff. So private cloud, again, it's $150 billion a year market. Amazon's doing about $5 billion a year, so it's kind of small. People love the public cloud, and they're trying to jam it together, and they call it the hybrid cloud. I fucking hate that term. I really do. And it's because it doesn't tell you anything about it. So I called it the problem cloud. So you know it's a problem. So at the very least, you know there's trouble there. So the problem cloud is defined as your private cloud gives you a lot of great things. So you can trust it because it's yours. It's highly decentralized and whole because everybody has one. There's 500,000 data centers in the world running people's private clouds. And paying for it's easy because you buy it, you rack it, and then the developers can use it and they don't have to ask for the credit card. But the problem is capacity management sucks. And the general opinion says it's hard to use because it's different. Like every system is different. So you go from this job to this job and it's different. The private cloud installs are different. So the public cloud is pretty awesome. Everybody loves it. And the reason why you guys love it are these two reasons right here. I know I spent like 2 years thinking about this. So there's plenty of excess capacity, and it's really easy to use. So that's fantastic. But the rest of this is what sucks about it. So it's mostly centralized. It's 8 data centers, come on. It's low trust. I don't know what Amazon's code looks like. Have you guys seen Amazon's code? Anybody? Nobody knows what it looks like. And they run a data center for the CIA. Payment systems suck. So like paying for it with a credit card, absolutely blows, right? It's not a way to pay for infrastructure. If I need a minute of server time, I'm not going to get that with a credit card. And then non-standard identity management. They make you log in the way they make you log in. So this is the problem cloud. So you get rid of all of the private cloud stuff. Those problems go away with public cloud. So if you jam the two together, you are left with basically the public cloud problems. It's centralized, it's low trust, payment system sucks, and there's non-standard identity management. Do we know of anything that will solve that? Anybody? Come on.
Blockchain.
The blockchain. The blockchain will save that. Bitcoin can solve these problems, and it can solve them handedly. That's what it's built to do. So what I'm working on, StackMonkey, is Bitcoin plus OpenStack. I'm going to talk about OpenStack for a second because you guys may not know what that is. So OpenStack is open source cloud fabric software. OpenStack's deployed worldwide now with thousands of deployments in production and hundreds of devs working on this code. So it's popular. Rackspace, in fact, we're in Rackspace's building Rackspace open source OpenStack. It's friggin' awesome. I run it at home. It's easy to use. Lots of eyeballs on it. Tons of companies. I just got back from the OpenStack conference in Hello? I got back from the OpenStack conference in Atlanta, and there were 4,500 people there. So it's a real conference now. It's serious. There's a lot of money behind it. So the StackMonkey project is a pool of blockchain. It's pools, like mining pools, and it's a blockchain monitoring virtual appliance that runs on an OpenStack cluster and controls the OpenStack cluster. But the virtual appliance listens to the blockchain for payments. So basically what you can do is send Bitcoin into this thing and it will start an instance, which I forgot to do. We'll do that here in a second. Does anybody somebody get their phone ready? Somebody has Bitcoin on their phone? All right, we got a volunteer. You're going to give me 50 cents, if that's okay.
It's like 250 bucks.
I know, right? I'm using my phone for my internet access, so. So just as mining pools are to crypto miners, compute pools in my world are to compute rigs. So you can install OpenStack, install the virtual appliance, start it up, start getting Bitcoin. People start running your servers on your own machines. So it's a co-op cloud. In addition to mining cryptocurrencies, operators can mine compute. So if you're mining on GPUs, you've got a CPU on the box that can be used for something else, you can actually make money off of the CPU as well. So you can imagine you could also start instances and actually mine with the instances, but that's not the intent here. You can do whatever you want with the instances you start. Tor clients, you can run BitTorrent on it, whatever you want to do. Run services on it. So I have a diagram, I'm not going to go into this because I'm going to go over I've got about 5 minutes left. And I want to do the demo. So if you want some details on how this works, I can go into that with you. So this is it, and what I'm going to do here, if my volunteer is ready to pay, multiple people want to pay, that's great. So what I'm going to do here is I'm going to click on this. And so what's going to happen here is that, and it'll give you an amount, and you'll have to pay the transaction fee. And so what's going to happen here is that the payment's going to go out into the network, and Coinbase is going to pick it up and do a callback to me on this virtual appliance. And it's going to use a piece of software called ngrok. And Alan, where are you at? Where's Alan at? The guy that wrote ngrok's over here, and that's an SSL tunnel. And so what happens is an SSL tunnel is formed, and then blockchain calls that SSL tunnel and it starts an instance on this. And so I've designed it in a way that basically you don't need an account to start an instance. So you can just make a payment, and you saw the payment come through right there. So the payment's being processed by the virtual appliance, It's going to start it up now. This is a
chip, yeah, I think.
Yeah, that's good. We got it going. So thank you, I appreciate it. What's your name?
Stefan.
Stefan?
Nice to meet you.
Thank you for the Bitcoin. And Brian too. So now what's happening, right, is an instance is spooling up on my OpenStack cluster at home, and it's going to grab an IP address, and it's going to make a callback again back to the pool controller, and then the pool controller can either say, I'm not going to talk to you, I need you to talk to somebody else to do another callback somewhere else for anonymous reasons. Or it can say, hey, boot up this particular image and then do these things with it and make another callback when you're done. And then that way, somebody can just come in to the, and what we're looking at here is the appliance. So the website is StackMonkey, but the website aggregates all of the appliances. So you can basically come in and you can say, I want 1,000 servers on 5 different continents, and then it'll give you a total, and it'll say, well, you need to give me, you know, a quarter of a Bitcoin to start this, and I'll run it for a week for you, or whatever. That's probably cheap. And then what happens is it'll go out and start all these instances and then aggregate all the view for you. But if somebody wanted an anonymous instance, they could just start one if they wanted to. So you could start a whole cloud, do a Hadoop job, shut it all down. And you can see here, you got a little timer running. So this is when these instances expire. And actually this guy is now running. And it's kind of cool. I'll take just a second to, I think I can click on this guy. I don't know if it's built yet. We'll come back to it here in a second. But when you click on that, it actually runs the presentation I'm running. So it's like already booted up and runs the presentation I'm running. So that instance is running, it's got an IP address. So Bitcoin methodology solves some seriously hard problems with cloud deployments. If there was one slide I want you to remember, it's this one. Because I believe that Bitcoin can save the cloud. I believe that's what it was invented for. I believe that's its purpose. I believe that compute helps compute. So Bitcoin is compute. It's the largest compute job we've ever run. And I believe it will help save compute. And if you don't think that compute's at risk, read this quote from John Chambers, the Cisco CEO. He says, you are going to see brutal, and he's serious. When you know he says brutal twice in a row, you know he's serious. That means he's fucked. He knows he's fucked. Consolidation in the industry, we're out of the top 5 players, only 2 or 3 of us will be meaningful in as quick as 5 years. People are freaking out. And I confirmed this at OpenStack conference. People don't know what's going to happen. And the reason why is that hockey stick graph you saw at the beginning, that exponential growth of compute, it's going to cause crazy demands of efficiency. And when you get really efficient, you get really close to the boundary of that growth. And when you're forced to that, things happen so quickly that it's just over in a matter of like, not even a year. It's over in like weeks. That's where we're going. It's kind of a complicated concept. So federation is problem number 1. This is the problem that we have to solve, and this is the problem that Bitcoin will help us solve. And I thought, I took the federation, you know, the Star Trek Federation, right? So Cloud Federation resource ownership describes a continuously shifting and competitive compute environment. That means that people are jockeying around trying to figure out how to make money, and figuring out where things are going. It's a big problem, right? And figuring out who owns the resources is difficult. And you can imagine that if all of us owned resources and we were all trying to reconcile our balances with each other, how would we do that without Bitcoin? We wouldn't. But we can do that with Bitcoin. Bitcoin can solve this problem. Standardization is critically important, how we actually do things, so that when you move from job to job or you move from server to server, it's standardized. OpenStack is open source. Bitcoin is open source. The Bitcoin protocols are open. So the way that we do things is critically important, and it has to be open. Infrastructure is meant to be open. It has to be open. So if you see infrastructure that's closed, run away from it as fast as possible. Bad mojo. Identity management is illogically difficult. So by the way, this is Spock talking to Spock, which is why it's funny. in theory. So it's really hard, but with Bitcoin, again, identity management becomes manageable because I can prove I am who I say I am, at least when I'm paying you, right? So Bitcoin was destined to save compute. This is what I believe it's immediate first use. I know everybody in the Bitcoin industry is like trying to figure out, hey, this is great technology, what can we apply it to? I'm telling you, you need to apply it to compute first. Because you apply it to compute, it's game over. Think about that, right? Like everybody relies on compute. So if you solve the compute problem that's looming, that John Chambers, CEO of Cisco, is saying that there's a problem, if we can solve that problem, it's game over on everything else. Everything else, it'll be waterfall after that. So bits of bandwagon bias, or how to hack an investor. I'm raising money, I'm raising a 3 million seed. I'm gonna hire people to build this. I've built a lot of it myself, so I'm very technical. I know how to talk about it. I'm gonna make this a company. The code is all open source. If you wanna contribute, there's a lot of ways, different ways you can do that. You can become a provider. You can write code to help me support the product. You can invest in me, or you can, contribute open source code. But bandwagon bias, I talked to Mark Shuttleworth at Canonical, this guy that runs the company that makes Ubuntu. And he said, what you said is blowing my mind. He totally got it. He wasn't confused. I wasn't being confusing. He totally got it. And he was like, this is an interesting idea. I talked to Jason Seitz, co-founder of SliceHost. He said, you just eliminated payment fraud. 10% of cloud service payments are fraudulent today. So anybody that's in the business of doing Bitcoin and letting people sell things with Bitcoin is going to help eliminate that. So we can eliminate cloud payment fraud. And this is the most interesting thing I've seen in at least 5 or 10 years. Now that I think about it, a friend of mine, Jim Curry at Rackspace, I presented this to him after thinking about the problem that they gave to me. And I said, I'm going to go off and build this, and they gave me my blessing. So I want to thank Rackspace for giving us this space and for their support and me thinking about this. They helped me a lot with it, and I'm very grateful. And I'm grateful for you guys being here tonight. Thank you.